Use the principle of mathematical induction to prove that 5 plus 8 plus 11 plus ... plus 3n plus 2 equals n times 3n plus 7 over 2. To use the principle of mathematical induction, first we need a statement about the natural number n. The statement P sub n is n times 3n plus 7 over 2. This is the sum of 5 plus 8 plus 11, and for each of the terms, we would simply add 3 to get to the next term. There are two cases in the principle of mathematical induction proof. Case 1 is the base case when n equals 1. When n equals 1, P sub 1 is 1 times 3 times 1 plus 7 over 2 when n equals 1, one term only. This is 10 over 2, which is 5. So we establish the base case for n equals 1. The sum of the first term of one term only is 5. Then we move on to the induction case when we assume the statement is true for n. We assume that P sub n equals n times 3n plus 7 over 2 is true. What does this mean? We assume that this sum is 3n plus 7 times n over 2. And we use this to show that the case P sub n plus 1 is true. So we consider the case P sub n plus 1. But what is P sub n plus 1? P sub n plus 1 is the sum 5 plus 8 plus 11 plus ... plus 3n plus 2 plus the next term will be 3n plus 2 plus 3. This is 3 times n plus 1 plus 2. Remember that we add 3 to get to the next term. But we assume that P sub n is true, so the sum of 5 plus 8 all the way to 3n plus 2 is n times 3n plus 7 over 2. We assume that this is true. Plus 3n plus 5. The common denominator is 2, so we would multiply 2 over 2 so that we can combine these. The denominator is 2. We have 3n squared plus 7n plus 6n plus 10, which simplifies to 3n squared plus 13n plus 10 over 2. And the numerator can be factored as n plus 1 times 3n plus 10 over 2. But remember that we want to have it in the form input times 3 times the input plus 7 over 2 to say that the n plus 1 case is true. And so we would rewrite it as n plus 1 times 3 times the input n plus 1 plus 7. And this is indeed 3n plus 10. We just simply rewrite it. 3n 3 plus 7 is 10. And we want to write it in this form because it now has the same format as the general statement. If we were to think about the general statement at the input, then P of the input equals 2 in the denominator, the input, and then 3 times the input plus 7. And with the input being n plus 1, this statement is true. Because of this, we can say that the induction case is true as well. By the principle of mathematical induction, we conclude that the statement P sub n equals n times 3n plus 7 over 2 is true. The sum of the terms is n times 3n plus 7 over 2. But not only for n. This is true for all n. This is the difference between the proof, the conclusion, and the assumption. In the assumption for the induction case, we only assume that it is true for n. But in the conclusion, we established that it is true for all n, not just one n, but all n.